This activity is based on a story about the military trying to come up with a special device to detect tanks that have been camouflaged in the forest. And this was a story from the 1970s, and you can imagine how back then it may be super duper useful to be able to have a technology that can see tanks that are trying to be hidden. So we're going to go through a bunch of images that we've created, so excuse the bad photoshopping please. And for each image that you see, raise your hand if you can see a tank in the image, and if you can't see a tank, leave your hands down. Let's go. Can you see a tank here? How about here? Tank or no tank? Is there a tank here? Is there a tank or no tank? What about now? Tank or no tank? Tank or no tank? So you can imagine that the images like the ones you had just seen, they were used to train the tank identification system. So basically, a tank classifier. And what happens in the story is that on the very next day when they took it out into the field, it worked beautifully, worked 100%. Every time there was a tank, it said that it saw a tank, and when there was no tank, it didn't say that there was a tank. But then, unfortunately, on the very next day, that same system started to make really, really bad mistakes. So, for example, it might have seen something like this, and it said that there was no tank. So this is something called a false negative. It's negative because it said there was no tank, and it's false because it was wrong. And if it saw an image like this, it would say, hey, there's a tank. And this is an example of a false positive. So it's positive because it said there was a tank, and it's false because it was wrong. So just take some time now, rewind the video, and look at the original training images again, and see if you can detect what might have happened with the system as it tried to learn whether there was a tank or not. So what's happened here is an example of sampling bias. Sampling bias is something that occurs during machine learning when the data that was selected or sampled to be used to train the system does not fairly or accurately represent the types of situations that would occur in the environment that you're going to use the system in. So you might have seen in the images before that every time there was a tank in the picture, it also happened to be on a sunny day. And all the pictures that didn't have tanks were taken on cloudy days. So the system learned that when there is a sun, it thinks there's a tank. And when there is no sun, it learned that there was no tanks. And you can see how it could do this because it's way easier to detect a yellow circle in the top half of the image than whether there was a camouflaged tank hiding in between trees. So this is another example of GIGO, garbage in, garbage out. The system will learn based on the data that you tell it to learn off. And it will learn the easiest thing and take shortcuts when they are available. So here's a more recent example where images were used to train an image classifier to classify whether a skin abnormality was cancerous or whether it was benign. So these examples on the top left were examples of benign or safe skin conditions, and the images on the bottom right were examples of malignant, cancerous skin conditions. So at first glance, these seemed to be okay, but there was actually a sampling bias in the images of malignant skin conditions, because some of them, when you zoom in, actually has little measurement markings there. So given the situation where images of cancerous skin conditions might have little ruler measurements, what is a possible shortcut that the classifier could learn, and what could be the worst case scenario that could happen in the real world if the classifier was used to detect whether skin conditions were cancerous or not? Well, because the measurement marks, those ruler marks, were only on the cancerous images, and they were not present in the safe images, what could happen is the system could learn that whenever there are these ruler marks, it would say that the skin condition was cancerous. Or alternatively, when there are no ruler marks, the skin condition was benign. And the worst case that could happen here is if someone did have a cancerous skin condition, but their picture did not have a ruler mark on it, then the system could think that it is safe. This is called a false negative. It's negative because it's saying that there is no skin cancer, and it's false because it is wrong. And the worst case scenario here is a person could go home thinking that all is well when they may have a cancerous skin condition. This is a very undesirable thing to happen that comes about because of sampling bias. And it just reinforces that data is so important when it comes to machine learning and artificial intelligence. Remember, garbage in, garbage out.